The first time we've had Nehalem architecture in notebooks, and as well as the first integrated graphics processor and the first 32 nanometer processor. So it's really a big step forward for us, and so far the silicon's looking very good. So we felt comfortable going ahead and betting our presentation on it this morning and presenting to you guys from it. The 4 series chipsets are substantially better than the 3 series, and our integrated graphics on CPU that we'll have with the Clarkdale and Arendelle, I think you'll be pleasantly surprised that we've improved the 3D performance there quite a bit as well. But that's really not the focus for those products. And I think we've had, despite some of the criticism that you mentioned, we've actually had a lot of commercial success with our chipsets. And we don't have any difficulty selling them at all, and I think it's because of what I said, that those that are really interested in 3D performance are buying discrete cards. From a performance perspective, we're able to share in the CPU cooling solution. It has some advantages there. We're able to better integrate the power delivery systems. Over the long term, as the architectures become more closely integrated, today we have a 2-chip solution inside the package, and eventually those will become a single monolithic design. As we move forward, we'll find more and more benefits, the ability to share power back and forth between the cores, and I think there will be long-term benefits. In fact, we have sampled CPUs to our customers for development purposes, but we're still being fairly careful with how we distribute them publicly. But we've provided detailed design guidance to all of our OEMs so they can design motherboards. We have customers that are doing evaluation and debug and validation today, as well as we are internally. No, not at all. I think our schedule for the integrated graphics CPU remains the same, even with the shift to 32 nanometer. It was simply a recognition that our 32 nanometer process was very healthy. We felt very confident in the health of the silicon, and by converging on a single product, a simpler roadmap, it's good for our customers. It requires less validation, testing, and development, and simpler supply chain, etc. So because of the health of 32 nanometer, we were able to simplify things. So we took advantage of that and went ahead and did it. There's certainly some things that scale very well with numbers of cores and numbers of threads. And we're certainly not of the position that microprocessor innovation is just about increasing the number of cores. I think we've seen in recent history that the speed of the core is at least as important as the number of cores. And there's certainly a number of products out there that have lots of cores, but nevertheless may not perform that well on a lot of workloads. So we continue to innovate in the core itself to improve the performance at any type of workload, so that we deliver the very best performance on single thread workloads, dual thread workloads, 4-thread workloads, 8-thread workloads. We're not advocating that one type of highly threaded workload is the only thing we care about. We're wanting to make improvements in all of those workload types, and we'll have improvements not just in numbers of cores and threads, but they'll have improvements in single thread performance as well. Of course, NVIDIA and Intel can work together, have worked together, and continue to work together in many areas. I think we just announced that we're going to be having SLI capability on our x58 Intel motherboard, for example. So obviously there's collaboration there.